Okay, we will like to do this circuit problem, and we will try to use all the laws that we have learned so far. And there's one new thing which is a dependent source, which I will talk about that during the solution of the problem. So here we can see that there are several sources and resistances in the circuit, and we need to find I1, which is unknown, and this V. These two are unknowns, and we have to find them. We can see here there is a current source, but the symbol is a bit different. Ordinary current source is like this, which is independent current source, but this is a dependent current source, and this one's dependence is 30 I1 is the value, and I1 is the current uh, on which this is the value of this source is dependent. That is, this is a current dependent current source. This is called CCCS. It could be also a voltage dependent current source. In that case, 30 times some V, it would be 30 or any constant times V, or just some V, which would be a voltage drop in any of the branches. So then the current source would be dependent on that voltage. So here it's a current dependent current source, so that's there. And other than that, we will have to use it just for the value. Other than that, we will have to treat it just as an element, and in this case a source. So first, what we shall do, we shall try to apply Kirchhoff's voltage law. Kirchhoff is probably the correct pronunciation, or Kirchhoff's. So let's apply the voltage law, KVL, here. And this loop, that means it starts here and goes that way. We are going in the clockwise direction, like that. We could have gone in counterclockwise direction, that would be good as well. And once we do that, we can see there are 4 elements in that loop. If we cover that loop, first thing to do is identify all the voltage drops and rises. So when we go like that, this is a voltage rise because this is a source. What about this one, 54 kilo ohms resistance? Of course, current is going in that direction. I1 is given. We don't know the value, but the direction is given. So the voltage drop will be in that direction. That will be voltage drop, because this dissipates power. It's a resistance. Similarly, here current, this one is I1 and this is 30 I1, which is given. So current here, we can just apply Kirchhoff's current law at this node, and if we do that, we can see that I1 is entering here and 30 I1 is coming from that. Both currents are entering in that direction, so this will be downwards 31 I1. That's it will be. We don't know the value of I1, so depending on whether the sign of I1, it can be in the downwards or upwards, whatever. That will be later. We will know about that later. We still don't know the value. We need to solve that. So let's first write all the voltage rises and drops. I will write them sum of voltage drop, algebraic sum. So the drops I will write as positive and the rises I will write as negative. So first we encounter this one, and when we go in that direction, because we are going in the clockwise direction, this is a rise, so I will write -5. Then this is 54 times I1, but that's a drop, so I will write 54 I1, Ohm's law. Resistance times current is the voltage drop. Then we encounter this voltage source again, and that's a rise when we go from the left to the right, because we have to always remember that we are going now in the clockwise direction. So that's a rise, again -1. Finally, the last element is 6 kilo ohms resistance. 6 kilo ohms. So we have to remember one thing. We are using kilo ohms as kilo ohms, so current will be in milliamps, because we needed to convert it into ohms, but we haven't done that. So voltage divided by kilo ohms will be milliamps, but that's fine. So this is 6 times 31 I1, and that will be equals to 0. So algebraic sum of voltage drops. Sum drops as positive and rises as negative. So once we do that, we get -6 here, and this is 54, and this one becomes 186, so 240 I1 equals to 0. So I1 becomes 6 divided by 240. So that is 0.025 and unit will be milliamps as I said before. So that's our I1. We can write that 25 microamps by multiplying this one by 1000, 10 to the power 3. If we do that, we get that in microamps. So 25 microamps, that's fine. Now we need to find the value of V. In order to do that, maybe I will use a different color. In order to do that, what we can do, we can choose this loop. We could have chosen the bigger loop as well, but I will just choose this loop there. Sorry. And I'm going now in the counterclockwise direction, CCW. So CCW, counterclockwise direction, and from here going to the counterclockwise direction. So 8 volts, that's again, and I'm rising the voltage drops and rises. So 8 volt again is, so basically writing KVL. 8 volt is a rise, so that's a negative. Then I have 1.8. So first I have to identify the drops here. Since the current 30 I1 is going from the left to the right, so this is a voltage drop like that. It's probably the same color, maybe, I don't know, this one. So that's there, plus minus, that's a drop. So we can see that's a drop, so that's plus 1.8 times 30 into I1 now we know, so we can write 0.025. So that is the current here, this much is the current because the current is 30 I1 times 1.8. Then we have this voltage V, which we do not know. So we have to write, because the way it's the voltage polarity is given, it's a rise now. So minus V. And then finally 6, this is plus minus. I forgot to give earlier one, but it should be the same in both cases. So that's plus 6 times 31 now into 0.025. So this is the current, 31 I1 times 6 equals to 0. So this becomes minus 8 plus 1.35, just plugging in the calculator. So this is minus V again, and plus 4.65 equals to 0. So V becomes minus 2 volts. That means the polarity of V will be in the other direction. So basically V is actually in polarity is like that, and that's 2 volts. That is the solution. So we have found the current and the voltages, and we have tried to apply KCL. We have applied actually Ohm's law, of course, because whenever we have written voltage drop across a resistance, we have used Ohm's law, and then we have used KVL and KCL both. KCL we needed here. So yeah, I will try to do few more, but this is just an introduction, a simple problem. Thank you.